Hi, I'm Tom Corcoran, Solution Architect with Red Hat. This is a discussion around Kubernetes stroke OpenShift operators, including instructions and a recording of how to create a demonstration of them. We'll use Red Hat OpenShift, the world's leading commercial Kubernetes distribution, as OpenShift is a complete Kubernetes distribution containing the Kube API and CLI. We'll use kubectl for most of our commands. An operator is a piece of software that runs on Kubernetes that embeds operational knowledge around your containerized applications. An operator allows you to automate and reuse that knowledge to manage your application on an ongoing basis. Tasks typically undertaken by operators include when and how to upgrade your application as new underlying components become available, application and data backup management, application patching, application scaling, either horizontal or vertical. An operator is like an extension of your engineering team that watches over the Kubernetes environment and uses its current state to make decisions in milliseconds. Currently, there are 3 operator implementation options of varying level of maturity and complexity. They are, first of all, the Helm operator for running Helm charts in a secure way, not requiring tiller, which needs root access and as such could be considered a security risk. Second, Ansible, offering further control by calling out to Ansible playbooks and roles. And Go, which could be considered the gold standard of operators, allowing you to embed your specific fine-grained control logic inside of Go code. Incidentally, OpenShift version 4, which will be released shortly in the first half of 2019, has a new feature called over-the-air updates, and they use the Go operator. So I refer you to my GitHub repo, github.com, TNS Corcoran, OpenShift-operators, for a couple of diagrams on the maturity model of the 3 different types of operators, as well as the tasks that each of them are capable of doing. But for now, we're going to launch into our 2 demos. First of all, we're going to demonstrate a Helm-based Nginx operator. The Helm operator is the simplest of the 3 operators supported by OpenShift. That said, it's a great way to run Helm charts in OpenShift without tiller, which as mentioned requires root access and as such could be considered a security risk. The diagram on the repo describes the steps that we will take, so I refer you there to get a visual representation of it. But let's actually just launch straight into the demonstration. First thing you need to do is SSH into your RHEL box and set up the Go environment. So I'm just going to kick that off. I'm already inside my RHEL box. I set up my Go path, download the Go distribution, install the Go dependency manager, and now I download and build my operator SDK, which is made out of the Go programming language. So that just takes a minute or so to complete. And the first thing that we'll do then is to, using our operator SDK, create a new Nginx operator, which we'll initialize using an API version and a kind initialization flag. These flags, the API version and kind, will be the indicator of what type of custom resources that this operator will operate on. So if there's any custom resources that are created with the same kind and API version, this operator and also they're scoped in either the cluster or the namespace that this operator has scope for, then the operator will operate on these custom resources. So here's my initialization. You can see we specify the API version of example.com v1 alpha and the kind of Nginx. So as I say, those will be the type of custom resources that this operator will operate on. What it does is it builds a directory that corresponds to the name that we created. So we're actually already in there. So take a look at the custom resource YAML file. So this is basically the instance and the configuration that our operator will operate on. So we're going to make two changes to the default that comes with this example. We're going to change the replicate count to 2, and we're going to change the port of the service to 8080. Now we save that. Now we're going to create a new Openshift project, or corresponds to a Kubernetes namespace, and we're going to do it as a developer user, because if we did it as an administrator, the developer that we're logged in wouldn't be able to see it. Next thing we want to do is to log in as administrator, and we want to create our custom resource definition, or our template for the custom resources, the Nginx custom resources. So as administrator, we'll create the custom resource definition, which has successfully been done. The next thing that we want to do is to install and enable Docker, because we're going to be pushing our operator image to a public registry. I'm going to use a Docker command to do that. So that's going to take a few seconds, and after installing Docker, it will enable it and it will start it. So that's running away at the moment. Following starting up of Docker, we'll do Docker login into our registry. We're going to use key or quay.io, which is a public registry that you can create a free account for. I'm going to log in. And I'm going to have my operator SDK to build an image that's going to be tagged with this particular tag here, the one that I have highlighted. And once that image is built, I can use Docker push after I've already authenticated to push that up to my registry. So that has been successfully done. I have actually got my web browser opened at my registry, and if I refresh that, I can now see my Nginx operator is just been created using my command line. Two things I need to do here. I need to enable the tag that gets created by default by checking the checkbox, and I need to make my registry public. By default, it's not public on initialization. What we now do is we're ready to build our operator in Openshift using a Kubernetes deployment object that references the newly published image on Quay. So what we need to do is modify the deployment object to reflect my image. So I do that with the sed command, which replaces the placeholder for the image with my actual image. So what we need to do now is we need to create a service account and a role. A service account is a non-human user with rights to perform actions. A service account is a non-human user, and a role specifies the rights that the operator needs to execute. And the third thing we need to do after the service account, the role, is a role binding, which connects the role with the service account and effectively assigns those rights to the service account belonging to the operator to allow the operator to execute its tasks. So I'm going to execute all of those commands in this series here. So it creates the service account. One of the things that we need to do to run this on Openshift is Openshift by default does not allow application containers to run as root. It's a security feature of Openshift, as having root access in a container can allow a container to break out, which we consider to be a security risk. So what we do here is, because this particular Kubernetes-based example does require root access, we need to actually override the default behaviors and allow the default service account on the NEID user to be able to give admin access. So that command there effectively grants admin access, or effectively allows the container to execute under admin access. Then we create the role where the access rights are. We create the role binding the service account to the role, and we create our operator following that. Next thing we do is we create our custom resource object that our operator will operate on. So now if I switch back to my Openshift console, I can see that while I've done that, just through that few seconds, what it's done is it's created the operator, and then it has once the operator has come up, it has created the two Nginx instances corresponding to the details in the custom resource that we created, specifically around the number of replicas, which we set to 2, and the port and the service account, which we set to 8080. Let's examine that. So if we look at our deployment, I'm going to run these 3 commands at once. I'm going to maximize this out. So first of all, our deployment shows our current and our desired states for both the operator and the actual Nginx instances are the same. They're 2 and 1 respectively. We can show the get pods, shows the operator pod and the 2 application pods. And then the third thing that we can see is the service is indeed running on port 8080 as we specified. What we're now going to do is we're going to change our custom resource that the operator is going to watch and effectively listen to and obey, if you like. And we're going to change the number of replicas up to 3, and we're going to delete our overridden service configuration. So here is our replica count, which is 2, and we're going to make it 3. And we're going to delete the entire service entry here. And we save that. And we use kubectl apply. So we can see here on the left we'll be able to visually see our number of instances going up to 3 when we apply that. And if we go back and we look at our service on the command line, you can see that the overridden port of 8080 has changed to the default port of 80. So that's just an example of how the Openshift operator acts on your changes to bring the actual situation into the desired state that we've specified. Now it's time to basically clean up everything we've done on the Helm operator. So we're going to delete everything that we've created here. Now we want to ensure that everything has deleted before we delete our namespace. Because if we delete our namespace while some of the dependent objects are still in existence, our namespace or our Openshift project will fail to delete. So we want to make sure that everything is gone, and indeed it is. So at this point we can delete our project. We go back to our project view. You can see that it has successfully deleted. That's it. So you've completed your first simple Helm operator demo. The second thing we're going to demonstrate is a more complex and a more powerful operator, the Ansible based GOGS operator. Again, refer you to my GitHub repo, where we have some documentation and diagrams. github.com TNS Corcoran Openshift-operators, which describes the steps that we're going to undertake in this particular demo, which is a little bit more involved than the previous one. So we are now obviously SSH'd in to our Linux box, our RHEL box, where Openshift is running. And what we're going to do is we're going to cd to the home directory, and we're going to remove any lingering operator functionality that we have from our previous demo. And we're going to basically reclone and rebuild our operator SDK. The operator SDK is obviously an SDK that wraps around the Kubernetes APIs, that allows you to, it basically creates skeleton operators for you, doing a lot of the work that you would have to do manually. So it makes the process of creating an operator much faster. So this time we have checked out a branch, the 02x branch, again from the same GitHub repo, the operator framework, github.com operator-framework operator-SDK. Incidentally, the operator lifecycle manager, which is coming in Openshift 4, will take care of a lot of this operator creation for you, but because that's still a tech preview, I want to do it actually manually, so we don't invalidate your support on your Openshift cluster. But like I say, in the next few months, and certainly in the first half of 2019, you'll be able to do a lot of these tasks without downloading and building the operator SDK. So now we've initialized it. There's a repository that's already been built. Again, this demonstration is based on a demonstration that is available on and reference on the GitHub repo, but there's already been a demonstration built, which includes Ansible roles, that sets up a Postgres database and a GOGS server that uses that Postgres database on top of Openshift. It contains an Ansible playbook that calls Ansible roles that do these two tasks, the Postgres management and the GOG server management. And what we'll do is we'll create a skeleton Ansible operator, and then we'll take these existing roles and playbooks, slot them in on top of our operator, and we'll take it from there. So the first things that we want to do is to download that repo that uses Ansible for our GOGs and Postgres creation. If we look at the playbook itself, you can see it basically is a parent which calls two Openshift roles, setting up and configuring Postgres, setting up and configuring GOGs. The repo points you at the YAML files where you can examine what actually goes on in there. There's quite a bit of configuration both around Postgres and around GOGs. So I'm going to create my operator using my operator SDK as an administrator. And the next thing that I'm going to do is I'm going to copy in the downloaded files from my existing Ansible operator into my skeleton Ansible operator that was just created by the operator SDK. It's overwritten those now. And there's also a watches file that basically is the going to be the main configuration for our operator. It's very simple. It has a version group and kind that our operator has been initialized with, and it has the playbook that we've just referenced as well. And if we look at the Docker file that's going to be used to build our image, that's going to be our operator image that's going to be deployed on Key or Quay again. It's very simple. It takes from here and it just copies in the roles directory, and it copies in the playbook and the watches. We're actually going to update the image that is in the Docker file with a newer image. Next thing I'm going to do is, again, I'm going to log in to Quay. I'm going to again build an image that is initialized as using the tag Quay.io TNS Cork and GOGS operator. Whenever that is done, after a few seconds, I'm going to push that up to my registry, and that will take a few seconds, and I'll repeat the same exercise that I did previously. You can see that my GOGS operator is here. I need to enable the tag that was set up, and I need to make it public so it can be pulled down into Openshift. It's private by default, so now I've made it public. The next thing we're going to do is we're going to modify the deployment, the Kubernetes deployment object, similar to what we did with the Nginx Helm operator. We're just going to replace the placeholder with my actual image that I've just created and deployed to Quay. And we are now going to take a look at my custom resource definition. You can see it's very simple. It just specifies the kind, list kind, the plural, etc. that our operator that will be used as a template to create our custom resources that our operator will watch and act on. Similar to before, what I want to do here is I want to log in as a developer user rather than an administrator and create a new project. Now I want to log back in as administrator on Openshift and create our custom resource definition, which requires admin access. That has been successfully done. Next, we want to create a cluster role, which will define actions that can be done at the cluster level. You can see the verbs here that it contains. We also need a service account. That's the non-human user account that will be doing the actions that the operator needs to do. And we're going to replace the role that we have with this role, which specifies what we actually need to be doing at the namespace level. Again, that's what we need to do here, all of these actions. And then the role binding, as we mentioned before, the role binding binds what the actions are to the service account and binds those to the operator, so that the combination of those two things allows the operator to do its work. So first thing we're going to do at this point, or next thing, is to create the operator. And we're going to watch it, watch and wait until it comes up. So the container is creating here, and that will take a few seconds as it pulls down the image and creates the container based on our Quay image that we just uploaded here, the GOGS operator. Just takes a few seconds, as you can see, and also confirmed by our command line. You can see the container is now running, so we can cancel out of that watch. Now we're going to use the operator to create a GOGS server, and the way we do that is to create a custom resource instance of type GOG server, which is our custom resource definition. So we'll create our definition here, our YAML file, and we will create our GOG server. GOG server what the as we mentioned, the GOGS operator effectively is going to create GOGS applications, and there's a dependent object within the Ansible GOG operator definition, which is the Postgres database. So it first of all creates the dependent object. That will take a few seconds to create and fully complete that. You can see that it's still working on that. Once the dependent object is created, it's going to create the parent object, which is the GOG server itself. So you can see that that's now that the DB is created, it's actually creating the parent object on which it depends. And it's still creating the container here. And this is now ready. So it only takes a few seconds to bring it up. Okay, let's have a look at what we've done here. So we'll cancel out of that wait. You can see that we have a GOGS object, which is our custom resource object with the name GOGS server. And if we look at its description here, you can see the various properties and fields that it has, the namespace that it's in, etc. The kind, which is the custom resource definition. Okay, one of the things that we specified is and use an SSL route. So we're going to demonstrate that now. If we look at get route, you can see that it gives us the host name here. And what I'm going to do is we've specified GOG's SSL as true in our custom resource implementation YAML. So what that does is it requires SSL to be used. So if I paste in my route without my, what I did was I pasted that in without the protocol. But what it does is because GOG's SSL is required, it's going to redirect. So if I refresh that, it's going to redirect to requiring HTTPS. So I'm going to have to grant, because this is an insecure self-signed cert, I need to manually grant access. And when I've done that, it takes me through to the GOG's application. Next thing we're going to do is we're going to create another instance of our custom resource definition, or we're just going to create a new custom resource. This time configured with GOG's SSL as false. So I'm going to paste all of this in. And if I go up here, it has started to create again our dependent object. After it completes that, it will create the parent object. What I want to do though is I just want to show you what the configuration of that custom resource that we've just created, the second one, GOG server 2, what that looks like. And the important thing here is GOG's SSL is false. So this one will not require SSL, and it will not require, it will not do a redirect as a result once we paste in the host name of the root. So this is another GOG's. So if I take that host name and I paste it in, because this is not requiring SSL, it's not requiring it to be an SSL or HTTP based route, it will take us straight there without redirecting. So it's almost time now to clean up and to delete everything. One thing that I want to show you is a feature of this more complex Ansible based operator is that you can have nested and dependent objects. So as you recall, when we created our GOG server, it first of all created our Postgres database and then our GOG server, because the Postgres was dependent on the GOG server. So there's a thing called an owner reference. So if I look at my definition of my GOG server, you can see that what it has is an owner reference. So the GOG's operator, the pod here corresponding to Postgres, has an owner reference of GOG server. That's actually very useful for us because it means that you, certainly for automation, if you go ahead and you delete the parent objects, it will automatically cascade down the tree and delete all of the dependent objects. So what we're doing here is we're going to delete our GOG server, and we're going to delete our another GOG server. So it's right now it's terminating the GOG servers, and it's terminating our dependent Postgres databases. So that will just take a little time to complete. Whenever that is done, we are report some errors. It doesn't shut down or close down in the most graceful way, but in the end it successfully deletes all of the objects. So now what we want to do is, as we mentioned before on the Helm operator, we want to delete all of our deployment, role binding role, service account. We want to delete all of these operator objects before we delete our namespace. We want to make sure that everything is gone. And indeed it is. Now we can delete our project, and we can also delete our cluster scoped objects that we created as well. So that's it. That's the demo. I'm Tom Corcoran. Thanks for allowing me to demo to you the two Kubernetes and Openshift operators, the Helm operator and the Ansible operator. As I mentioned, the instructions for running today's demos are available at github.com/tnscorcoran/Openshift operators. Hope you enjoyed it. Thanks.